In this video, we will discuss about one application of operational amplifier, that is non-inverting amplifier. How operational amplifier can be used as non-inverting amplifier. We will also discuss the theory of the study of operational amplifier, that is IC 741, as a non-inverting amplifier. I will show you in practical in a separate video the study of operational amplifier, that is IC 741, as a non-inverting amplifier. But in this video I will talk to you about the theory, and also I will discuss what are the probable questions from non-inverting amplifier. In the previous video I have discussed about inverting and non-inverting terminal of the operational amplifier. This is the basic circuit diagram for the operational amplifier, and this end, positive end, is called the non-inverting end, and this negative end is called the inverting end. Non-inverting means the output wave or the output of the signal will not change. Shape of the output of the signal will not change, but in inverting amplifier the shape will change. There will be 180 degree phase shift in inverting amplifier, but 0 degree phase shift in non-inverting amplifier. So this is a non-inverting amplifier. The input voltage is given to the positive terminal and the negative terminal is earth connected. So in non-inverting amplifier, input voltage is given to the positive end. Since the input impedance of the operational amplifier is high, the voltage drop across this point, that is at the point G, is equal to V1. The voltage given to the input, that is equal to V1, but in this operational amplifier at the input you have high impedance. So the voltage drop here at the point G also equal to V1, and this is your input resistor. R1 is your input resistor, and RF, this is the feedback resistor. I have discussed it in the previous video, that is inverting amplifier. So you should first watch inverting amplifier before watching this video. So what will be the current through the input resistance R1? As you know, current is equal to voltage divided by resistance. So input voltage is equal to V1 and resistance is R1. So current through this input resistance is equal to I equal to V1 divided by R1. Suppose this is equation number 1. Then what will be the current passing through the feedback resistor RF? Okay, you see the output voltage is equal to V0. The output voltage you have taken V0, and the input voltage equal to V1, and here the input voltage also equal to V1. So what will be the difference in voltage? The difference in voltage is V0 minus V1. So V0 minus V1 divided by the resistance, that is RF, that will give you the current through this feedback resistor RF. So you can write the equation for the current passing through the feedback resistor RF, I equal to V0 minus V1 divided by RF. Suppose this is equation 2. And from Kirchhoff's current law, we know the total incoming current is equal to the outgoing current. From Kirchhoff's junction rule or current rule, the incoming current here must be equal to the outgoing current. So you can write V0 minus V1 divided by RF must be equal to V1 divided by R1. This equation, from this equation V1 by R1, and from this equation V0 minus V1 divided by RF. So you solve this equation. If you solve this equation, then V0 minus V1 divided by V1, you take V1 this side, that will be equal to RF divided by R1. So V0 divided by V1 minus V1 by V1, that is equal to minus 1. So that is equal to Rf divided by R1. So what will be V0 by V1? That will be equal to 1 plus Rf by R1. And what is V0 by V1? This is the output voltage and this is the input voltage. And the ratio of the output voltage to the input voltage is called the voltage gain. So this is the expression for the voltage gain for the non-inverting amplifier, operational amplifier. From this equation, it is clear that voltage gain for non-inverting operational amplifier is greater than unity. Okay, and also the voltage gain for non-inverting amplifier is positive. This thing you have to remember. Why it is positive? Because there is no phase difference between input and output. That is why the voltage gain is positive and voltage gain is greater than unity. So this will be a long question generally asked in the examination. Derive an expression for voltage gain in non-inverting operational amplifier. So you have to deduce that the voltage gain V0 by Vi equal to 1 plus Rf by Ri. And why the gain is positive? You have to write the gain is positive because there is no phase difference between input voltage and output voltage. And also you will see that the voltage gain is greater than unity. Why the voltage gain is greater than unity? This may be a short question. So in experiment to study the operational amplifier, that is IC 741 as non-inverting amplifier, what you will study, we know the voltage gain is equal to V output voltage by input voltage. So the input voltage given to the amplifier is known to you. The input voltage generally we give from 0 to 1 volt, and the resistance, that is the input resistance and feedback resistance, these are also known values. Only the unknown value is output voltage. So you divide the feedback resistance divided by the with the input resistance, and 1 plus Rf divided by R1, you can calculate it, and that must be equal to the voltage gain, that is output voltage divided by input voltage. If the value of 1 plus Rf divided by R1 is equal to output voltage by input voltage, then this is a study of the operational amplifier as non-inverting amplifier. And we will verify it in experiment in the next video. Another question generally asked in the examination, what is buffer amplifier, and draw the circuit diagram for unit gain buffer or voltage follower. Why non-inverting operational amplifier acts as a unit gain buffer or voltage follower. What is a buffer amplifier? A buffer amplifier is one that provides electrical impedance transformation. When there is only transformation of impedance, here you see in case of operational amplifier, the input impedance is high and the output impedance is low. So there is impedance transformation, but there is no voltage transformation. If the input voltage is equal to the output voltage, there is no voltage transformation. Only you have voltage follower, but impedance, there is transformation of impedance. So a buffer amplifier is one that provides electrical impedance transformation, and your operational amplifier or the non-inverting operational amplifier, that also acts as impedance transformation. So, and the next question is, draw the circuit diagram for unit gain buffer or voltage follower. If you short circuit the feedback resistor, I have short circuited the feedback resistor. So if you short circuit the feedback resistor, then it is called unit gain. The gain will be unity, because as when you short circuit it, the RF, the resistance of the feedback resistor will be equal to 0, And what will be the resistance of the input resistance? The input resistance will be equal to infinity. Okay, because the input impedance is very high, so input impedance resistance is infinity. So the voltage gain will be equal to output voltage divided by input voltage, that is equal to 1 plus Rf divided by R1. We have reduced it, so 0 divided by infinity, so that will be equal to 1. So the circuit is called unit gain buffer. If you short circuit uh, this one, then the gain will be unity. So it is called unit gain buffer. Why buffer? Because only there is transformation of impedance. It is also called voltage follower. Since input voltage is equal to output voltage, it is called voltage follower. And this circuit offers high input impedance and low output impedance. Thus, non-inverting operational amplifier is used in impedance matching devices. So these are the probable questions asked in the examination. And if you like this video, then please share and subscribe. Thank you.